Hello. Today, we're happy to say that our project is ready. We've been able to fix everything on the board to access power from the solar energy. And so, let me show you what. Let me take you through the components on the board. Right. So, this is what we have. That's a complete set. I'm very happy. I like it. So let's start. We have the shunt over here. This is the shunt, and this is the one that probably regulates the current outflow from the batteries, and then it reads how much current or how much amps we are using from the battery. So the battery goes to this terminal. I'm here to connect the battery to the terminal. It goes through the shunt to the bus bar, negative bus bar. So from here, all my negative leads takes their source, and this particular one takes its source all the way to the MPPT charge controller. This is the device that takes power from the solar panel and makes it possible for the battery to be charged. So my negative goes in there, and then from the bus bar, it continues all the way to the power inverter, and this is the inverter that converts or inverts the DC power into AC power, and I can connect my AC leads from here to power my electrical gadgets and components. So that's about the negative lead. Then we come to the positive lead, the battery should be somewhere here. The battery is connected to this particular fuse, and it goes through this one all the way to a bus bar, a positive bus bar. This positive bus bar also supplies positive energy to my component. So I take um, the positive from here all the way to the charge controller again. Remember, we did the negative to the charge controller. Now we are taking the positive from the bus bar into the MPPT charge controller. Then we continue from our power, that's the positive from bus bar, up all the way into the power inverter to make it complete. So now we have negative lead, positive lead, and then the negative lead. And the negative goes to the negative bus bar through the shunt, and the positive also comes through the bus bar through a fuse. And this fuse can trip off when there's a problem, so that I can save my cables, I can save my wiring, as well as my components. Now, there's this small device here, that is the Bluetooth dongle. Yes, you can see that's a Bluetooth dongle. It enables a kind of makes it possible for me to be able to view what is going on in the system as in terms of current that is withdrawing from the battery, and I can monitor that on my phone. So this enables me to monitor what I needed to see on the phone. And the same thing goes to this particular monitor, but this is the physical one fixed on the board. So assuming I'm not around the board, but I need to check how much current I'm using or how much is left, I can monitor from here. But when I'm not around, the Bluetooth device will make it possible for me to check it on my phone, and we're going to go through that very soon. Then I have the fuse box here for my DC components. So I take the power source, positive and negative, I fish them through behind the board, and all the way I take the source from here, the positive and the negative bus bar. So that also goes through the fuse box. Then out of the fuse box, here and there, I have power supply to my DC sockets. So I have a DC socket here um, that opens up, and I can put in my jack or my electric cigarette jack to get a DC power. This particular one is a voltage reader, but I love it because it gives me a reading in terms of percentage as well. So I love that very well. This particular hole, I'm yet to put in something. I'm just waiting. I don't know what to fit in there, but I'll check that out soon. And then I have a switch to control all the DC output. Therefore, it goes on and off, and then I can terminate power as well as give it power. This is the amp meter that takes its source from the shunt. The shunt makes sure that I can monitor how much I've used from the battery, and this meter will give me that readings. I love this piece, even though it's not as detailed as the other ones, but I love it. It gives me the wattage, it gives the amp hour, it gives me voltage, and also it gives me the watt hours. I love it so much. And this is an isolator switch, just on and off isolator switch, which controls my solar panels. So from the solar panels coming through the system, and I were to work on that line, I can isolate power. I can isolate solar system power, then I can work on it. So it's just an isolator for the solar panels, as well as this is an isolator, even though it's a trip device. It's also an isolator from my to the battery. So it just go like that. That is on and then off. So far, so good. That's all we have. So all I have is that this is a cable from the solar monitor, which goes through into the MPPT controller, and then also I have the dangle, which I fish through the board. So it goes behind the board, also comes out to the charge controller. Let's see the back. Let's see what we have at the back. Yeah, this is how it is at the back. It looks kind of clustered and complex, but it is not that difficult. It's not that difficult. This is just this is a fuse, actually a fuse from my solar panels, so that something happens if I have too much voltage coming from my solar panel. This can also terminate that. So I think for now that is what we have. Yeah. So let's go inside and fix this, connect to the battery, and see if it works. Okay. Um, the battery lead is connected. Um, so we have to try and check and see if what we got is correct. So take the voltmeter, put it on DC, and let's see if we can get correct reading. So positive to positive lead, and then the negative to negative lead. Okay, we have 13.06. Let me go before the shunt. 13.06. So it means there's no loss. It means our connection to at this point is correct. Again, let's try from here to the negative post here. 13.05. So we yeah, 0.06 there about. So we're on track. Everything is okay for now. So let's put in power and see what happens. So let's turn the breaker on and see what happens if we can have everything working. So breaker, yeah, we have everything working. Um, so we have a reading from the solar monitor which gives me 13.10 volts, which is the volts on the battery. We have this small gauge here. I love it so much, and this can give me in percentage. That is it. That's why I have 85% of my battery state of charge, and I have this socket. I don't know if this one will work. Let me switch this on and see. Okay, I need to do a connection there. And then this particular screen is showing voltage 13.1, just as this one is showing 30.1, so it's accurate. I'm drawing 0.03 amps or probably 0.3 watts, so I'm not drawing that much. Nothing is connected yet. And also have the watt hour, the energy that I have used so far. The oscillator is there. So at this moment we have power in the battery connection in there, so we can now safely turn on our solar input. And let's see what we have a solar input here. Yes, so far we are waiting to see what happens. There's a 0 watt coming in, so we'll have to wait for it to reset. So here we are. We have 36.4 volts coming in from the solar panel. That's 135 amp hours from the battery, and then we also have 1791 watt hours used. This is 1.2 amps. That is the battery amperage for now, and then we have 13.17 volts from the battery. Let's see. The solar panel is giving us 16 watts. It is very cloudy, very cloudy there. You can see very cloudy, so we can't get any serious wattage coming in. So this is what we are having now. Probably when it is sunny, we might go as far as 150 watts to charge the battery. I have 86% there, and I think that's about it. Let's turn on the inverter. Okay, so we have 13 volts coming into the inverter, and it's giving us 230 volts. Let's plug in something and see if this will work. Okay, so we're going to follow this cable, go through there, and that is it, to this particular extension wire, and we can see its light all the way to where we have another mess of wires here, cables, and I have the extension. So I can unplug all these things for now and plug in my what we call it, this digibox. Plug in the digibox and plug in the television cable as well, and then that is it. So we have power in here for the digibox, and then we have power on the TV. I got to use the remote control, and then I will turn on the TV. Do we have? Yes. Okay, let's see, it's blinking, means there's power that's in there. Okay, we have power in the television. What do we have? Okay, we have television working, and then machine is working. I can plug in all my devices here, and then so I can plug in some of them here. So that's about it. Now this is my battery bank. I have a set of 12 volts battery, 18 amps each, and I have 8 in a row, 16 of them. So I'm getting 18 times 16, about 288 amp hour battery here. which is very good for me for now. All is connected in parallel, and I have to join these two banks at the end there, but it's all in parallel. And that is the negative lead here, all the way to the negative post, and I have the positive that is also coming in all the way to the positive post, and that's what I have. So I can plug in my 12-volt appliances here. I can also take them from my fuse box. Yeah, this particular I didn't speak about. This is DC to DC converter, and you can take direct voltage from the solar panel, and this will make it convert it to 12 volts, usable for 12 volts appliances. So I don't need to go through all this mess. I can just take power straight away from the solar panel into this particular DC to DC um, converter, and then I can use that one as well. So I'm happy, and if you like this, give me a thumbs up.